It's time for another installment of Precision ASMR. Yes. These will be our measuring instruments today. A pair of digital micrometers with clutch tightening mechanism and a pair of digital calipers, which, believe it or not, are very accurate, pretty accurate. More than accurate for most of the stuff I do, such as building little devices like, say, this. What's this? This is a machined fixation tool, you see. This will be used in an upcoming video. Yeah, so we can get the camera to be as precise as my damn measuring tools. Yes, we will use this to, you can almost see into other dimensions in the focusing crystal. Stainless steel, aluminum, tingolonium, focusing crystal, brass, aluminum. Anyways, things like this are made using measuring instruments like these. How so? How so, you ask? And don't worry, we're going to measure lots of strange things like party beads, or I forget whatever they call these. Put those around my neck for the time being. How about BBs for a BB gun? Those would be pretty important to be accurate. We'll check those out too. And then we have just a kind viewer years ago, like probably 3 years ago, sent me in a care package, and in it was a whole bunch of arts and crafts things. I'm talking like everything you can think of. And if that person's watching, I hope they know that I have used their stuff in a million different videos in one way or another. But this is an unopened bag of rings. I'm assuming these are going to be pretty accurate because they're machine produced. Just basically a long length of metal tubing, solid metal tube. Well, a tube would be hollow. Solid metal wire just snipped and then snipped. And then this, I thought, again, you can see I haven't opened these, but I am very curious because these are mass produced, how accurate these would be. And then I think in a future video, if we were to take these and do the end grains opposite of each other and like glue it up, just each piece one at a time with a brush, a little bit of glue, stick it together, do it on wax paper, a little bit of glue, stick it together, until all of the, I have a couple bags of these, we can make a big mosaic board. That would be pretty cool. Anyways, we're going to measure these. I think that would be kind of neat. And then, well, put the instruments over here. Then we're going to do stuff like this little wooden hammer. You know, like, how accurate is this part of it in different areas? Or the main handle. Just something silly. And then the common tongue depressor. We can measure this widthwise. I'm curious. I bet you its dimensions distance between here and here along this length are pretty accurate. And I bet you its thickness is pretty accurate too. Not from edge to edge, but I think in a linear measurement, I think it'll be pretty accurate. Again, because these are mass produced and they're pretty stable. The wood's brought to a certain moisture. Alright, let's stop talking. I'm going to start off with a very interesting piece. This here is a setup block or a gauge block. It's shop made. It's not mass produced. You can see it's made by. Let's see if we can. It says best microphones in the business, but my camera is junk. There you go. Number 2, JK. This was literally made probably before all of us were born. I'm thinking sometimes in the 50s, maybe the 60s, more than likely the early to mid 50s this was made. This was made out of a piece of tool steel, then hardened, and then precision ground. So you'd say, well, Doc, you know, big deal. You're holding a piece of metal. Nah. Nope. This is an extremely accurate piece of metal. I'm going to give you an example of why a piece of metal like that is very important. A little diagram, as it were. And then we'll go to measure. Okay, so here's an example. I'm on the lathe. And this will be a top-down view, so this is my lathe, right? And this is my Lathe Chuck. The chuck is the part that holds the part that I'm working on. These are the jaws. And when I insert a key into these little things, it looks like this. And I tighten it. It makes the jaws tighten in on the part. Now, there are circumstances where I'll have a piece of metal in here. And let's say, for example, I'm making this piece here, right? And I've already made all of these cuts and grooves and all that. And it's time for me to remove this from the bar that it was originally connected to. I have to do what's called parting. Now, when I bring the lathe carriage with my tool, that's the tool for cutting or parting off a piece. So here's the piece I made, right? I want to remove this from the raw stock. This tool has to come in, and while the lathe is spinning, it has to cut this piece. it is extremely crucial that this part, this piece, the cutting tool, is perfectly at a 90-degree angle to the workpiece. It has to be square. It can't be like this, or it can't be like this. Otherwise, this whole face will be cutting the workpiece. It won't work out. So what do? Well, the technique I use is the face of the chuck is extremely precision and in almost a perfect 90-degree angle to the axis of the lathe work, the workpiece. So the face of my chuck is 90 degrees to the axis of the lathe. So what I'll do is I'll put this tool up against the face surface of my chuck, and then I'll turn my carriage crank until the tool face touches the surface of this tool. I will loosen the bolt, the nut on top of my tool post, which allows me to rotate my tool post like this, making the tool go at different angles, you see. So now when I bring, let's say this is the edge of my cutting tool that we're going to use to part off this piece here. I'll bring the carriage over until it touches. This is flat up against the face of the chuck. If it's like this, I'm exaggerating it for example purposes. You can see that's way off. That would not cut into the piece squarely. So what I'll do is, as I turn the crank and I bring the carriage over the tool, this will start to turn and it will go flat against this piece, at which point I will then tighten the carriage nut. When I bring the carriage back over this way and remove this, and in this case I'm using it as a gauge block, this is now going to be, the cutting tool will be perfectly parallel with the face of the chuck, which then in turn makes it perfectly 90 degrees to the axis of the rotation of the workpiece. Do you understand? Okay. Now, how accurate is it? I didn't have to put that last one in there, but I'm feeling a little crazy today. This was made way before even I was born, out of some tool steel in a shop somewhere, and I believe it probably would have been the Boston area. Let's get our micrometers turned on. We'll zero them out. Okay, perfect. So, like I said, I use this surface and this surface to go between the chuck and my cutting tool. So, how far apart these are is important for maximum parallelism. So let's just take some measurements between these two surfaces, and just the warmth of my hand can change all the dimensions of this tool steel. So when you're doing super high precision, measuring hand temperature, room temperature, even the temperature of the tool can literally change it depending upon how. You know what we're going to do? Let's do it like this. We're going to clutch it up, right, on this end, and we're going to zero it out. We'll just do a comparative reading, so let's just double check that. So that's 100,000s, 10,000s, thousands, tenths, and I forget what the fraction of tenths is called, but millions, that's millionths. Yeah, okay. Now let's go to the middle of the piece. It's within 5 millionths. Now let's go to the far end of the piece. So over what is this? Let's see. I think it's 3 inches. Okay, 4 inches. Wow. I'm a machinist, don't you know? So it's 4 inches long. So over a 4-inch span, it is absolutely perfectly parallel. And we have to take into account these are cheap. This micrometer is a cheapo Harbor Freight micrometer, so that's 5 millionths of a tenth. I bet you if we were to, yes, it's just it could just be in the clutching. It could be this is center. It's also in the way I'm see. I wouldn't be doing it like this if I wasn't on a camera. You see, 5 millionths, and then the far end once again. That was the width. The thickness can also be used. So let's bring it to here, on this end here. See what we're doing. Before we measured this distance, now we're going to measure this distance. So let's tighten it up. Zero it. Confirm. Okay. Now we'll go to the middle. Could be in a piece of dust, yeah. 3 millionths off. And then the far end. 0. So again, over a 4-inch span, it is within millionths of accuracy. Well, Doc, what does that mean to me? What does millionths mean? Okay, well, let's do this. I'll use the Sharpie so you can see. How accurate is that bar? Okay, so a piece of paper. Well, I'll show you. It's always fun doing this. People are like, oh, that's cool. I didn't know that. That's a little fun fact I can share at the office party. Okay, first of all, I gotta zero this out. Zero it out to actual 0. Average sheet of paper is usually a couple thousandths thick. So let's measure how thick this piece of paper is. almost 3 thousandths thick. And of course that's of an inch. I'm not doing millimeter measurements. So that's 2 thousandths. About 2 thousandths of an inch, almost 3. We'll call it 3 thousandths. Okay, now here's a piece of paper. Blown up. And we called it, we'll just call it 3 thousandths of an inch. Okay? If we take one of those 3 thousandths, which would be 1,000th of an inch, and we then split that up into 10 increments, 10 slices. We took that one, broke it down in 10 more slices of measurement. These would be tenths. 10 tenths make 1,000th. And then to get down to millionths, we have to take a tenth and further reduce that. So when I tell you that over a 4-inch span, this is accurate. Well, I actually read 0 from end to end, but the furthest variation we saw was what, 1 or 2 millionths? A millionth is 1,000th broken up into 10 places, and 1,000th is 1/3 the thickness of a sheet of paper. Ladies and gentlemen, that's precision. Let's get on to measuring some cool things. I think we're going to start off with these rings. I think these rings would make for some interesting. Another beautiful piece of precision. Now, take some random. Let's just dump out a couple of these. Wow, this is turning into a long-ass video, huh? You know what, before we do, the wood cubes and the BBs, just for funsies, let's do the, you know what, let's take the caliper. Let's make sure we're all good to go. Okay, here we go. We'll start. Should we do it like this? I have to do it in a way that I know I'm being. Here we go. So, 266 thousandths. The next one is going to be 268. The next 268, 266, that's a little bit oddball. No, 268. Of course, if you rotate them, they'll change, because they do have a mold line. But I'll know if I hit the mold line, because it'd be way too big. 7. 264, turn that a little bit. Yeah, 264, that's a baby one. 266, 265, 267, 268. So something as simple and goofy as Mardi Gras beads are as accurate to each other within 2 or 3 thousandths. Again, if you take an inch, 1 inch, and you slice it into 1,000 pieces, these are accurate to one another in relation to one another within 2, 3 to 4 thousandths of an inch. That's pretty accurate. But that doesn't surprise me. Mass-produced things generally are pretty accurate. You know what? Let's get the babies out of the way. Now, I know these will be accurate because they have to go through a barrel, right? So 174, 174. These are all going to measure to be 174. Every one of them. I guarantee you that. 174. We'll do one more. That's 5. That's a pretty good sample size. 174. So these 5 came to, I think I measured BBs in a video once before, but you know what? I mean, it's a common item that people can relate to. You know, you gotta be able to relate to the folks, you know. Okay, zero that out. Now let's get down to real high level accuracy. Now this is 173, 5/10ths, and 5 millionths. But we don't have to get down to millions, so we'll say 173 thousandths and 5/10ths, or half a thousandth. This one, 173, 5.5, 173.4, 1/10th off, 173.4, and 173.4. So extremely accurate. Again, not surprising. Meant to go down the barrel of a BB gun, so they got to be close. Because if one of these are, let's say, so we're at 173.4. Let's say this thing got produced incorrectly and came out to be 175, it would probably get jammed in the barrel and damage it. And if it came out to be 170 thousandths, it would probably just bounce violently as it goes down the barrel. And then when it comes out of the muzzle, the end, it would be very inaccurate. So it's important that these little teeny beeny baby bits of ammunition be accurate. Ladies and gentlemen, enough messing around. This video is going on much, much too. Micro-milled titanium. Do some M390 blade steel with a mirror polished cutting edge. Mirror polished. Yes. If a fly landed on this edge, he would just slice right in half. Pretty gross. insert built-in over travel with a ceramic detent ball. The action on this knife, perfect centering, is superb. You can deploy it one of the three ways: a spidey flip from behind, a standard flip from the front, or, I don't know if you knew this, but this design is called a front flipper. You can flip it three different ways: from here, from back here, or from right here. Oh, and then there's just the fancy way. You just hold the hole like this and go. But anyways, let me put that away. Demonetized. Now, of course, a great many things can affect wood precision, and that would be moisture, and grain. So we're going to choose to measure these on the end grain. You see, this is the grain running like this. That's the end grain. So this was going through, and we cut like this. Here, here. And that's where I think the most accuracy would be, where they get lobbed off. So they would be in a long square stick like this. And all of these are running, the grain is running this way. So we're going to measure them end grain to end grain. Let's just get a quick summary. 631. Whoa, 582. That's that guy's fired. 591. 584. Yeah, these are all over the place. I'm surprised. Very surprised. 582. It's pretty close to this one. 584. Let's see. That's more like it. 596. That guy must have been smoking. 580. That guy must have been smoking substances that are not Tingle Bottom Industries approved. That being tinglerium, tinglonium, or liquefied tinglopidus. Okay, just for funsies, let's measure the face sides. So let's see, like this one would be 576, 565. I don't know, this factory must be a lot of users of fudge. A lot of fudge users, this factory. So this way, 587. This way we get 567. That's 30 thousandths. That disgusts me. 567. 570. 580. 529. The guy that cut this piece of wood probably chopped off his arm that day. I mean, I hope not, but he wasn't paying attention. I bet you this one's pretty good. Let me see, 577. I mean, when you go from things like this, 741, 742, 742, 742, 742. I'm just measuring just all over the place. 742, 742, 742, 742. Okay, from that to, 566, 575, despicable, 577, 604. Ladies and gentlemen, I wouldn't use these blocks
these together and make them look like super cool, I'm gonna have to just really just cross my fingers and I'll wish for the best, but I think that'll come out. And then, so here's a little, so if you want to see the grain, like this is a nice piece. This is this isopropyl alcohol. Watch this. Let's watch this little experiment day. So this, we'll say, this side measuring opposite of this side. Okay. Right down the center, we get 577. Okay. Let's put a little isopropyl alcohol in there. Bring the wood grain. Look at the beauty of that wood grain. So beautiful. Look at that. I think that's all I need there. Still not fully. And we'll dab it down just to get the excess off. Okay, here we go. Well. I don't even remember. I think we climbed, what, 10,000? Was it 577 or something like that? 584. Pretty sure. Well, you guys can always click the rewind button, but I already know. I don't have to click rewind. I know it's bigger now than it was when I first measured it because it absorbed alcohol. Even if we measured this 5 minutes from now, it would shrink. It actually looks like it might be shrinking right now. 583. Yeah, a little bit. Yeah. 582. Slowly drying back out. Okay. Ladies and gentlemen, I would like to thank you today for coming and indulging in the world of measuring once again. I do so enjoy making things like this beauty right here, the Tingle Scepter. We will be using this in a video real soon, ladies and gentlemen. Real soon. Focusing module. Taking the tingulonium and then precisely, where's my pointing to it? Making the radioactive tingulonium amplified by this module. Amplified by this module. Camera. Oh, you're so lucky. Amplified by this module, the tingulonium is focused at this extreme point right there. Swarovski crystal point right there. Giving the such a powerful burst of tingles. Just a slow rotation. You can see the multi-dimensional. You're seeing into the tingle dimension in there. Do you see inside that stone? It's tingle dimension. But this, ladies and gentlemen, is for another video altogether. Let's put it up on a little stand, shall we?
to say one more positive thing. What can I say? You guys are the best audience on YouTube. And you already know that. You already know that. Every YouTuber says that, but they're full of shit. They're full of boobies. I mean it when I say it. And those of you that have been following me know that I mean it. Once again, I love you guys. And I'll see you in the next video.
Now I've got a complete mess to clean up while you guys go get to fall asleep.
Night-night, good night.
Sleepy, sleepy night. Don't worry, Doc will clean up all this disaster zone. Yeah, I know, we didn't do the tongue depressor. I think we'll survive without measuring a tongue depressor. Oh, look at that. Yes, I'd rather do a draw cut because I got too much. Yeah. I'd like to send this knife to Doug Linker. You ever see Doug Linker's channel? He carves all those little people out of basswood. I'd like to do this like as a challenge, the Doug Linker challenge, and say, hey Doug, carve one of your little Christmas Santas using this.